Hey guys, Quiff the Lazy Geek here, and it's been a while since I've featured my Hyperstar telescope on the channel. But tonight I have the opportunity to use it again. I'm now fully ready with my two rigs. So this is the Celestron C6 Schmidt-Cassegrain telescope put together under this hood here, and I'll go to that in a moment, with a Hyperstar lens that changes it into an F2 super fast imaging system. And on the other side of the equation here, here it is, I have this Newtonian scope that I've been spending a lot of time on the channel recently. And tonight, it's going to be a clear night. We're in the middle of the rainy season. It's near the new moon. The Newtonian will work at playing around with a tiny pixel camera. I'll be testing this camera on it. I'll feature that in a different video. That's like what the QHY53715C, I believe. If I've already published that video on the channel, I'll put links above somewhere. So that telescope there will be working on something completely different, M101 as a galaxy image. But while it's working on a galaxy, we'll have this telescope working on, I hope, the Eagle Nebula, haha, M16, with the very famous pillars of creation. And one of the reasons why I haven't been using the Hyperstar is because for some reason, I have been experiencing what I call the donut of doom kind of problem with Hyperstar. And this is something that I had experienced when I first started using Hyperstar, and something that I had started experiencing again randomly recently. And it's basically when you get your whole image, it looks great, you have the target, you have everything, but you have kind of like the shadow of the secondary or the shadow of the Hyperstar lens that's projected onto your image, and it's almost impossible to get rid of with calibration. The root of the error might be miscalibration with poor flat frames, or in my case, because I know that historically it's been working, more likely something to do with light leaks or light reflections within the system that can then cause a slight mismatch between the shadow of the secondary when you're taking your flat frames and when you're taking your light frames, and then you get an emboss kind of effect on your image. So to fix that, I decided I wanted a longer dew shield than the 3D printed blue dew shield that I have featured on the channel before. The 3D printed dew shield that I featured before, by the way, don't worry about it. It's being used right there on my Newtonian telescope. It's just like, it's perfect fit, even though it was built for the Celestron C6 Hyperstar in the first place. But it works great, so I'm gonna keep it there for now. But for Hyperstar itself, I bought from the US, from Amazon US, with huge import fees, the Celestron Dew Shield, which is longer, has really a nice fit, has some clips there at the back to really secure the dew shield in place, and it has this little dew shield cover as well to really keep like the telescope in the dark during the day. On top of that, it has an area in which you can route cables, which is what I'm doing for Hyperstar. Normally it's made for like power connectors, a thermistor connector for dew shield, that kind of stuff. I didn't buy like the Celestron dew heater ring, but this is a very convenient kind of solution. And inside, it's pre-flocked with very non-reflective type of felt inside, and it's just like, it felt like something that would help me get rid of that donut of doom, to have like a really good imaging experience. And the dew shield itself, I bought it off of Amazon.com for $90 because all of the other places didn't have it in stock, and I paid something like $50 in shipping to get it into Japan because it's not sold locally. I've tested this. It gets completely rid of my donut of doom issue. And I believe like the main reasons for that are the length of the dew shield, longer than my 3D printed dew shield. There, the felt lining in the inside to avoid reflections, But on top of that, it's also the repeatability of that view shield. It's always at the same angle. It's never moving around, which was not the case with my flexible view shield. So that's where I was coming from. I took a bet, a $150 bet or so, to import this to Japan, play with it, and hope that it would solve my donut of doom issue. And for now, it seems to have done so. So it was a great investment. By the way, if you're interested in this view shield, it's a fascinating little thing for Celestron telescopes, not just the C6 that I have here. It works really well for Hyperstar, and it's not cheap, but it's not outrageously expensive either. And apparently combined with like the U heater ring, it can work really wonders. So I'll put links in the description if you're interested in that. Now, of course, behind the view shield, I have my Rising Cam IMX 571 sensor camera. So APS-C size sensor with the 3.7 micrometer pixels roughly. So we're going to play tonight with this one-shot color camera on my f2 system. And of course, within the filter drawer, I have this magnificent ALPT filter, Antlia golden filter, which, as I recall, is 5 nanometer band passes for hydrogen alpha and oxygen 3, which are two colors or band passes or wavelengths that are emitted by nebulae like the Eagle Nebula. And for tonight, that filter is going to be super, super important, because one of the reasons I almost never image the Eagle Nebula is that it is so low near the horizon. I think at most it gets 40 degrees above the horizon. And when I'm normally imaging, I tell Nina to stop imaging a target if it dips below 40 degrees, because then I know I'm not getting good signal to noise ratio because of the light pollution smog in Tokyo. Especially when we're approaching summer, the smog in Tokyo stays in place. So we have like this haze in the atmosphere that is great at reflecting light pollution. I can almost read a book on the freaking balcony without any additional lights. Actually, I don't even have to say almost. I already did. So yeah, definitely not ideal conditions, and I have no idea what results we're gonna get. But, I'll get imaging. I have, of course, my mini PC here. This is the Melee Quieter 2 PC. The Astro PC that I featured recently on the channel is on my Newtonian. But all fun stuff. And of course, as always, links all over the place. So what is going to be a strategy to kind of vanquish the light pollution besides the filter? Well, not much, actually. And I will want to drizzle. So I'll be dithering, meaning moving the telescope slightly between each exposure. And I will be then drizzling, which is artificially increasing the resolution based on the dithers that were made. It's a whole cool concept that I detailed in another video. I'll put links above. And then using the drizzled image, I'll be able to use the excellent deconvolution tool, Blur Exterminator, in PixInsight to try to eke as many details out of the Eagle Nebula as I can. And in all of that, because I'm going to be drizzling, I don't want to be taking too many exposures. So even though I'm f2, I'm going to try to go for 5-minute long exposures. So it's not going to vanquish light pollution. It's not going to do anything. It's probably going to blow out the stars, but I don't really care. We're just going to play around, because that's what's fun with this hobby. You can play around. You don't always have to be like making a picture that is going to be worthy of an APOD or a prize or whatever. It's really not why I'm into the hobby. I'm just here to have fun, and this is what we're going to do tonight, as always. So I'll see you maybe for the imaging session, if I have the energy to get the camera out or record my screen. Sorry, I'm here to have fun. Sometimes I don't feel like taking YouTube videos, but at the very least, for the processing in PixInsight, we'll be together to try and see how well I was able to take the Eagle Nebula, those pillars of creation, through the Tokyo smog with my f2 telescope, the ALPT filter from Antlia that really excludes a lot of the light pollution, and through some nice weighing formulae in my PixInsight weighted batch pre-processing, which I'll go into some details a little bit. I've shown it in the channel before, but I'll show it again because I feel like my method works, at least for Tokyo, may be marginally better than the default stacking and weighing methods in PixInsight. So If you want to learn more about that, stay tuned. Before we go into the imaging and or the processing, or at least the processing, I want to give a quick shout out to my Patreon supporters and my channel members. It's thanks to you I can make some stupid purchases like this that actually solve my problems. Awesome. And then of course feature them on the channel to teach you about all of the stuff that's available, because that's what I love doing. So thank you so much to my Patreon supporters. If you want to help me keep the channel running, of course, besides just watching the videos, leaving comments, leaving likes, subscribing, which already makes a huge difference. If you want to give more support, you can go in the description, check my Patreon link and join my Patreon or join the channel. It truly, truly makes the channel possible. With that little message out of the way, let's get going with the imaging and the processing.
Okay, and we are in PixInsight the following day. We've done our exposures. I got 55 frames of 5 minutes each. Yes, I exposed a long time, even with Hyperstar, because we're using narrowband, and I don't really care about my stars getting clipped, meaning they get wider than what the sensor can support. And that's fine. And so I got 55 frames of 5 minutes each across the night. And so I wanted to mention exactly what I do these days to do the weighting of my subframes. And this is my understanding. It's actually, I'm not even sure if it's correct, but my understanding of how this weighting formula works. Now, by default, in the latest weighted batch pre-processing versions in PixInsight, you get the PSF signal weight as the default weighing algorithm. But in this case, and actually recently, I found that I still sometimes get better results with my weighting formula. And in my weighting formula parameters, I set just the number of stars that are detected by the stacking algorithm as the main criteria. Because I like number of stars. Like the fewer stars you have, the less in focus they are, or the more sky glow there is, or the more clouds are coming through. And it might not work as well with an uncooled sensor, but with a very well-behaved cooled sensor like the IMX571 in my TobeTech camera that I'm using, it works really well. And so the number of stars, you can set any number because it's relative to all of the others. Like at 0, I could just like be setting it to 100. And then there's another parameter called the pedestal. And you can see when you hover across the pedestal, you see that it is the pedestal added to the weight, meaning that if a weight would be like almost 0 based on the number of stars, it would still have like a relative weight of 10, right? So you're setting a pedestal. How much do you want to count your worst frame in your stack? Now, for me, I saw that some of my frames had basically 0 stars. So the frames that have 0 stars, they're not going to be an issue. They were cloudy, smoggy, whatever. The registration isn't going to work. So they're not going to be counted in the stack. So no problem there. But the frames that did have some stars, the registration, so the star alignment, will likely work. And so I set a pedestal that is really low because they're really low quality frames. I'm still counting them because I'm nice, but I'm setting a very, very low pedestal. So my best frames will have like the full weight and my worst frames will have the pedestal. So those are the settings that I use when I know that I have like really bad frames together with good frames, depending on the weather, the smog, the tracking, the light pollution, etc., etc. And on top of that, of course, what I did is I also went under calibration. I set my de Beer method to bilinear. Normally it should be VNG, but I'm setting it to bilinear because in post-calibration, we're having the drizzle of 2 times with the drop shrink of 0.9, which lets us increase the resolution. The problem that I have here is that I realized I made a mistake in my dithering definition. I dithered every 3 frames, which isn't really enough for drizzling. We're going to try it anyway, but I expect to see some weird Bayer kind of pattern come up even like after the stack, but we'll see. And when I say we'll see, I've actually already done the processing, so I already know. Okay, so now let's have a quick look at the resulting image with my 2-time drizzle. Here it is unstretched, Let's stretch it with a control click here to have an unlinked stretch. And here is how it looks like. It looks pretty neat, actually. So what processing do we do when we have an image like that? It's the usual. First, I did some dynamic I removed the stars first. Then I did some dynamic background extraction, much smoother. Let me redo a screen transfer function. You can see that now we can see much more of the image. I did a second round of dynamic background extraction just to adjust the gradients a titch more, but already you can see a lot of information in there. Then I placed back the stars. Don't forget that if you use this method for dynamic background extraction, when you do the DBE or when you do the ABE, the automated background extraction, you want to check the normalize checkbox. Otherwise, when you re-add the stars, they'll be like weird. Anyway, we've re-added the stars, and now I can do some photometric, or actually spectrophotometric color calibration. So now instead of control click for unlinked stretch, I'm going to shift click for linked stretch, and now we can see the natural color based on the spectrophotometric color calibration. Now that I'm done with that, I can actually flip the image geometrically, because since I'm using Hyperstar, I have a single mirror and then lenses, meaning that the image is flipped from normal orientation. And now I flip it back, and we're back to like a more standard orientation for the Eagle Nebula. Then I could do some blur exterminator. Let's have some fun and look at the before and after. The magic of blur exterminator on drizzled images. It's amazing. Now, if you look closely enough in some areas, you can see some like straight vertical and horizontal lines. This is the issue that I was referring to with me not dithering enough because of a mistake that I made during the setup of my sequence. But such are things. You can also see like weird banding colors here at this zoom level, and that's also the same reason. It's gonna get better once we resample the image. Okay, so what we do afterwards, we do some noise reduction. So this is before noise reduction, after noise reduction, and we use Noise Exterminator, another of the amazing plugins for PixInsight. And then I resample. So you can see now I've done a 2-time resample to go back to the original resolution of my camera sensor. And we've already taken advantage of Blur Exterminator and Noise Exterminator. So even with the resample, we still have a lot of detail in the image, which is really, really nice. Then I used Bill Blanchen's stretching script to go to this image here. This time, I don't have any screen transfer function applied anymore because we are stretched. So my next step was to remove the stars, because we're just going to do all of the processing without the stars and re-add them at the end. And then do some HDR multi-scale transform to make the core a bit less blown out of the nebula. Once done, I was able to perform the HOO normalization, another one of Bill Blanchen's amazing scripts. I did some changes to the HOO normalization. The biggest one is that I set the normalization mode to C normalization, to here to 1. And that made a big, big difference for the core of the Eagle Nebula. And then I added a yellow mask, which again I built using Bill's scripts. I played with some curves to make the yellow like kind of like more reddish and yellow. And then I played with the blue mask, and you can see the before and after of the blue mask. I just reduced the luminosity of the blue mask to make the blue punchier. And then it's just like curve to kind of make things like more punchy, like playing with the saturation, playing with masks, all this kind of stuff. Another round kind of like contrast to really get a punchier image. And then placing back the stars. I did then a first round of reducing the stars a little bit, and then I used Bill Blanchen's star reduction to really, really make the stars less intrusive in the final image, which is this. So how amazing is this? This is a single night of data. It's on the Eagle Nebula that's in really the Tokyo light pollution, but we get such a cool image here. I love this hobby. And it really goes to show the power of the Celestron C6 plus Hyperstar. So we're at f2 super fast optics with the cool, the TopeTech IMX571 camera, super clean sensor, really easy to deal with. And then you add on top of that the very narrow band dual band filter from Antlia, the ALPT, that is targeted for fast optics in my case. So that's for my Hyperstar, for RASA telescopes, for even like fast Newtonian telescopes with the Starizona Nexus focal reducer at f3, that kind of stuff. This kind of setup, even from Tokyo, on emission nebulae like the Eagle Nebula, can give you amazing results in very, very little time. So absolutely amazing. And I'm also super stoked that my new Dew Shield from Celestron is now solving my Donut of Doom issue, and we're really like back to like really cool images with hyperstars that I can play with. Life is good. Of course, all of the links to my equipment are in the description below if you want to have a look. And if you want to support me, remember there's Patreon link in the description, joining the channel, subscribing, liking, leaving a comment. Let me know what you think of this image and this processing. I'm planning on doing a live where I redo this processing from scratch. So maybe it will be up by the time I release this video. If so, I'll put the link up above if you want to see all of the nitty-gritty details of the processing. With that, as always, thank you so much for watching. Don't forget whenever you can to look up at the stars, and I'll see you next time.